2, 1, go.
Are you sure there's nothing about it there?
No, it doesn't matter. Right, cool. Alright, hey guys, as you saw in the video previously, we were demonstrating a pencil case falling down from my friend's hands to the ground. So, we calculated the estimated time, which was 0.94 seconds. We figured out pretty much the final velocity, which was 0 since it hit the ground, and it stopped. We calculated the height from which my friend dropped it from, which was 1.47 meters. The gravitational acceleration, which is negative 9.8 meters per second squared. Well, that's generally the gravitational force that we all know. So, what we're going to do is we're going to apply it in a specific formula, which is final velocity squared equals the initial velocity squared plus 2 times gravitational force times delta y. So now that what we're going to do is we're going to discover the VI, the information that's missing. So step 3. Introduce the identities that we have into the formula that we have, into the formula that we apply. You can also use it in other formulas, but the other formulas will have less identities. So if you could gather as many identities as you can inside one formula, that will benefit you in the long run, because you might get a wrong answer if you just take a shorter one, which we could have used, which would have been in final velocity equals initial velocity plus acceleration or gravity times delta time. That would have given you a wrong answer. We tested it out and it would probably mess you up. So we just went along with it. So the final velocity is 0, so squaring it will give you 0 again. You can't do much with 0 pretty much. But maybe at our level, but later on maybe you could. So the initial velocity, we are missing it. And now we have 2 times 9.8, negative 9.8 times 1.47. Alright, now what we're going to do is we're going to isolate the initial velocity, which will give us this. Now we have to put it positive because the formula would not work in this situation. So because initial velocity is positive in this situation, so it wouldn't really matter. So what we're going to do, sorry, I'm just going to correct it everywhere. The initial velocity will be, well, what we already calculated gave us 5.36 meters per second. So that was the initial velocity in our situation. Now what we're going to do is step 4 is we're going to do verification, which is pretty simple. You just take the information we already had, all the information we had, except you're going to make one identity that we already know, like the one we know already. For example, we're just going to make delta y unknown, for example. So we're just going to redo this entire formula pretty much, except the y is going to be the one unknown, and we're going to apply the initial velocity that we know. So it's going to be very simple. So what we do is it's going to be 0 squared again, but this time with 5.36 meters per second squared plus 2 times 9.8 times delta y, which is unknown now. So what we're going to do is we're going to pass over everything that's addition first. So this is going to give you negative 5.36 squared. And then it's going to be divided by 2 times 9.8 to give you delta y. And then afterwards, in the end, it's outside since what we do is this entire, because my friend asked me why is the negative outside. The negative is outside because this is one full number altogether. So when you move this number that's already squared technically. So you move that entire number and it will be negative no matter what. So that will be squared, and then afterwards it's going to be negative since you moved it to the other side.
Fair enough.
And afterwards, it will that's why it would cancel out with the negative information there. So we're going to continue on, and in the end, the delta y will give you 1.47 meters. That's the way you could verify it, pretty much, if the formula is correct and you did the right measurements and pretty much the right identities were applied. So in this situation, we found that it gave us 1.47, coming back to the exact measure that we had before. And this was pretty much our, wow. Thanks for listening, and this was Rocket Science 101 1D Kinematics. Yeah.